Hello. Today we're going to look at average rate of change on arbitrary intervals. So previously we looked to find the average rate of change on a specific interval. So we found the average rate of change of, for example, f of x equals 3x minus 5 on the interval from 0 to 1. But now we're going to do something a little bit different, and this is going to be very useful for us in calculus. We're going to be finding the average rate of change of a function. So for example, f of x equals 3x minus 5 on an arbitrary interval. Now what that means is that instead of having the starting and ending points be numbers, we're going to express them with variables. And so we're going to look at the interval from a to a plus h. You might have been expecting me to say from a to b, which of course is reasonable, but in calculus, we need to be looking at the interval from a to a plus h. Now, what does that even look like? Well, let's take a quick sketch of just a generic graph, some function. Let's say that we are looking at a graph that looks like this. And so what we're doing is we're looking from a starting point, A. So we're looking at the point A, comma, f of A. And we're moving to a second point. But instead of calling this A, we're going to call it A plus H. And what that means is that we start at A and we move a distance of h units further. So this distance is A, and then we move h units further to A plus h. And then this is going to be the point A plus h, comma, f of A plus h. So we're going to effectively be looking at the slope of the secant line that goes through these points. But instead of knowing their coordinates in terms of numbers, like 0 and 1, we're going to be looking from A to A plus h. This is going to seem a little weird, but it ends up being very important in calculus. So what we're going to do is we're going to do this problem right here. So the average rate of change is going to be the difference in the function values. So it's going to be f of A plus h minus f of A over the difference in the x values. But the difference in the x values is going to be A plus h minus A, which ends up being just h, which should hopefully make sense because h is the distance between these two x values, so it's going to end up being the difference. So we're going to have f of A plus h minus f of A over h. And this is going to be the formula that we use to find the average rate of change of any function between the values a and a plus h, those x values. So now let's go through. Actually, I am going to box this in because this ends up being important. We're going to be using this in several examples. So now let's go through and let's plug in A plus h and A to our function. Might seem weird at first, but you will get used to it with a few examples. So our function f of x is equal to 3x minus 5. Verbally, this means that we take the input x and we multiply it by 3, and then we subtract 5. So here the input is a plus h. So a plus h gets multiplied by 3, and then we subtract 5. It might seem weird. I'm going to use a highlighter here. But what we've done, because we're doing f of a plus h, we're plugging in a plus h where x would be in the function. Then we're subtracting f of a. So if we evaluate f of a, if we plug in a for x, we're going to have 3a minus 5. And this is all going to be over h. Now we have to simplify this expression. We can distribute the 3 in the first pair of brackets. That gives us 3a plus 3h minus 5. And then from that, we're subtracting 3a minus 5 all over h. Now, when we've got one polynomial minus another, we need to distribute that subtraction if we want to get rid of the grouping symbols. So we're going to have 3a plus 3h minus 5, and then minus 3a plus 5. And it'll be plus 5 because we're subtracting a negative quantity all over h. Now we have some canceling that occurs. We've got positive 3a and negative 3a. We've got negative 5 and positive 5. And when we cancel those out, we're left with 3h over h. And 3h divided by h is 3. So the average rate of change on this arbitrary interval is going to be 3. Let's look at one more example. This one's going to be a little bit different. Our answer is not going to be a number. There's going to be some variables in it. And so I want to compare and contrast these two examples. So the next example I want to do, I want to find the average rate of change of the function g of x equals x squared plus 5 on the interval from a to a plus h. So same interval as the last one, but just different function. So to find the average rate of change, we need to take g of a plus h minus g of a all over h. This is going to be more complicated algebraically. So let's look at g of a plus h. This is going to be our function g, but instead of x as an input, we're going to have a plus h as an input. So wherever we have x here, we're going to replace it with a plus h. Let's do that now. So instead of x squared plus 5, it's going to be a plus h squared plus 5. And then minus g of a is going to be a squared plus 5 all over h. Now we have to multiply out a plus h squared. That's a plus h times a plus h. You can FOIL that, or you can recognize that it's a special product. A squared plus 2ah plus h squared. And then, of course, plus 5. And then minus a squared plus 5 all over h. Now, we need to distribute this subtraction when we're getting rid of the grouping symbols here. So we can keep all the terms from the first one just as they are, a squared plus 2ah plus h squared plus 5. And then we're subtracting a squared, and we're also going to have a minus 5 because we distribute that subtraction all over h. Now let's see what cancels. We've got a positive a squared and a negative a squared, a positive 5 and a negative 5. So all of those cancel, and then we're left in the numerator with 2ah plus h squared, and that's all going to be over h. Now what we can do is we can divide both of these terms by h, because they're both divisible by h. 2ah divided by h is just 2a, and then h squared divided by h is h, and so we end up with 2a plus h for our average rate of change. Now, why did we get a constant for the average rate of change in the first problem, but an expression with two variables for the average rate of change in the second problem? Well, for the first problem, the function we're looking at is a linear function. It is a line with slope 3, and so it doesn't matter what interval we're looking at, the average rate of change is always going to be 3, because that line is always increasing with a slope of 3. However, this second function is not a linear function. It's a quadratic function. We know that the graph is going to be a parabola. And so what's happening, if we look at different intervals, is that we're going to have different rates of change depending on the intervals that we're looking at. Some of them will be positive, some of them will be negative. The average rate of change, therefore, actually depends on our starting point A and also how far our interval is moving to the right, h. Now, it's difficult for us to interpret right now what this 2a plus h means, but once we get to calculus, we're going to be spending an entire month effectively looking at this, but going more in depth. We're going to be talking about limits, we're going to be talking about slopes, instantaneous rates of change. It's a whole big topic, and we're just looking at this particular concept now to prepare ourselves so that when we get to calculus, it's not quite so difficult.